Hi, we are going with to deal with today B plus tree. Myself Sukrit and my friend Gaurav Shah. So, what basically B plus tree is? A B plus a type of balanced search tree used frequently for indexing the database table. Or we can say a B plus tree is a variant of a B tree which stores stored data in a way that allows for the efficient insertion of a retrieval and a removal of records, each of which is identified by key. So why B plus tree? When we make a use of large files, sometimes we are going with a process a randomly set of data as well as a sequentially. So we can deal with the situations with the B plus B tree also, and the data mainly they are processed in the B tree, but by almost in a popular file organization method. But sometimes it fails. That is due to the high processing time normal speed. It won't work in a B tree. So rather one is the variation of a B tree. One is B plus tree is used. So now we come with the definitions of a B plus tree. I have already told that B plus tree is a special case of B tree. So it will satisfy some of the conditions such as our properties such as the root has at least two child nodes and at most have m child nodes. The internal nodes except the root have at least m by 2 child nodes and at most m child nodes. All these were just some conditions for the B tree. But some of the additional conditions for the B plus tree such as from the root to the leaf all paths should be of the same length. When a node is not an either a root or a leaf, then it has a children between n by 2 and n. Some special conditions such as when a root is not a leaf, then a minimum of two children, that it should not be a 0 or a 1, at least it should have two children. When a root is a leaf, that is no other node except the root in the tree, what I'm going to tell it's, and then it can have a children between 0 to n minus 1 values. So let's go for the searching in a B plus tree, or your searching operation in a B plus tree. When a key field is searched, the leaf node has a value for all the values of the search field, which also contains a data pointer to the record or a block. When a non-key field is searched, the pointer points to a block which contains pointers to the data file records, which results in an extra level of indirection. So since there is no structure change in the B plus tree during a searching process, so what we have to do, just we have to compare the key values with the data in the tree and just then give the result back. Searching in a B plus tree is similar to that of the binary search tree. So we are going to search 15 and 45 in the tree given below. So we are first gonna look for where the 15 falls. That is, we can see that 15 is less than 25. So that is what we basically go start from the root. So we see that 15 is less than 25 to move to the left subtree of 25, and here we comes and search for all those values. That is, 4 values are present: 5, 10, 15 and 20. So we find it successfully, that is 15 is present. And next we are going to do with the 45 is that same thing again, we are going to check for the root node, that is where 45 falls, that it's not less than 45, so we increase that, it's greater than 20, but here is a condition, it is less than 50. So we can say that we are going to do with the right subtree of 25 or a left subtree of 50. We're gonna check with this in this mid value. So we're gonna find all those two values are present, 20 and 30. So we see that 45 is not present, so we can just conclude that 45 is not present in the B tree, B plus tree. Sorry, B plus tree. Now we're gonna do with the insertion in a B plus tree. In a B plus tree, every node corresponds to a DEX block and is kept between half full and completely full. Inserting into a node which is not full is quite efficient. So certain steps to insert a new node in a B plus tree are as follows. Insert the new node as a leaf node. Then if the leaf node overflows, split the node and copy the middle element to the next index node. If the index node overflows, splits the node and move middle element to the next index node. So we are going to look with the inserts an example. What we're going to do is that we have taken some random tree values, 28, 70, 95. We're going to illustrate all three values. So how to insert is three values. First, we're going to look with 28. So it's the same way what we have done during the searching in a B plus tree. We have to look for where this 28 will fall. We're going to compare with this 25. Yeah. It's 5, 10, 15, 20, this values. It's not less than, it's greater than 25. So we just quit this. We just skip this and move forward and see as it's less than 50. So it stop here and we're gonna down look here for this values. It's two elements, 25 and 30. So we just gonna shift this 30 because we can't insert 28 over here in this third position. Because it will just it will not have all those things. It will not maintain the. It will just violate the rule. And what is that? The key value should be inserted 28 in this node. It's just look like this. What I mean to tell that if we again, if we took this 28, we don't insert over here and just shift here, it will violate the rule and it doesn't satisfy all those conditions. So, and the nextly, we are going to insert the 70. So, I left this condition and it will continue by my friend Gaurav Shah.
Hi, I am Gaurav Shah. I will discuss last part of B plus tree.
So now we have to insert 70 in this B plus tree. So we will check that 70 is greater than 25 and also it is greater than 50, but it is less than 75. So the 70 will be inserted to the right subtree of 50, that is in this node. So if we insert 70 in this node, then it will become like this. But here one problem is there, that is the leaf node overflows, because we know that if the order is n, then any node should have maximum of n minus 1 elements, but here as the order is 5, so in this node the maximum number of elements is 4. So now we have to split this node into two parts, like first part will contain 50 and 55 and the other part will contain 60, 65, 70. That is, we have to split in this way, as 60 is the middle element, so it will be inserted to the index node and after 50, so it will become like this. So this is now our B plus tree. And after that we have to insert 95. So 95 will be inserted in the right subtree of 75, as it is a greater than 25, 50, 60 and 75. So if we insert 95 in this node, that will become 95. Here also same problem is there, like the node overflows condition. So we have to split this node, and 85, as it is a middle node, it will be inserted to the index node. Here in this index node contains the 5 elements that it violates the rule, and it is the overflow condition. So we have to split this node into two parts, and as 60 is the middle node, so it will be split from there. 25 and 50 element will be the left subtree of 60, and 75 and 85 will be the right subtree of 60. This is the B plus tree. So this is all about the insertion of the B plus tree. Now we will go for the deletion in B plus tree. Deletion of B plus tree also contains some steps, and these are as follows. Delete the key and the data from the leaves. Then if the leaf node underflows, then merge that node with the sibling and delete the key in between them. If the index node underflows, then merge that node with the sibling and move down that key in between them. So we will check the example for deletion in a B plus tree. In this tree, first we will delete the 70. If we delete the 70, then it will just simply remove from this node. The tree will become like this. And now we will delete the 25. So if we delete 25, so we have delete 25, then this 28 will be shifted left, and as 25 is present also in the parent node, so we have to delete the 25 also, and 25 will be replaced by 28. So this is our B plus tree now, and now we will delete 60. So 60 is present here and also here. So if we delete 60 from here, then this node contains only one element, that is the underflow condition, because it should have minimum of two number of elements. So we have to now, as we can say that this leaf node is underflow condition. So now we have to merge these two nodes, and as 60 is present here, so we have to remove this node also. And if we remove this node, then we have to merge these two nodes. And if we do so, then at last our tree will like this. So this is our final division. This is our final tree after deletion. This is our final B plus tree. So this is all about the B plus tree. Thank you.